All right. Happy Monday. So, this is 4.05 day number 3, which means you have a quiz today after this lesson, actually. All right. So, we got two problems on the screen. So, most of you are done with number 1. So, go ahead and chat. Go ahead and write what was your final answer? What is the length of side BC? Two decimal places. We got 2199. Got some more 2199s. All right. Let's see if that's right. 2199. Yes, that is what I got as well. All right, we'll go over these in a second here. Let's go ahead and let me just do a quick poll. All right, give me a green check if you are done with number 2, and X if you are not done with number 2. So again, check if number 2 is done, X if you are not done. Maybe I should just like kick people out of this session if they're not here. What do you guys think? You think that's a good idea? Like if you're not here, just go ahead and boot you out. Yeah, maybe. If I have people on my third ask of who's done, not done, or here or whatever, if they don't answer again, then I will just start booting people. What's the point of showing up? You're just going to fall back asleep. Right. So let's go over number 1. Before we do, this is 4.05 applications of the law of sines and cosines. All right. Surprise, we're being recorded. All right. I went over this kind of Friday, very end, talking about when you want to use one versus the other. Simplified form of that. So, law of sines, you really want to use that usually when you have side side angle or angle angle side, and then law of cosines, side angle side or side side side. And if you're not really sure, you can just go at it with one of the formulas. Just I'm going to use this one, and then once you try it, you might know. I don't know about pretty quick, but you'll eventually know. You probably chose the wrong formula if you run into a major problem, and a major problem could be you just can't solve it. Like you have more than one variable you're trying to solve for, or the math seems overly complicated. So major problems. And then, if that happens, you just try the other formula. So you only have two choices, right? It's law of sines or law of cosines. It's not like you're trying 8 different formulas. Well, why is major in quotes? Well, major is, well, once if you chose the wrong formula, you would see major problems. All right, so let's look at number 1. So in chat, what did you guys use to solve number 1? Law of sines or law of cosines? Law of cosines. Um, I think I agree with that. So we're trying to solve for BC. So I'm going to put, Where's my pen tool? So we're trying to solve for, side BC, which is opposite of angle A. So I'll just call that little a. So yeah, this would be a side angle side. So yeah, law of cosines. I agree with all of you. So we have a squared equals all that stuff plugged in. And then we just square root everything and you type this in. Make sure you are in degree mode. Don't use Symbolab. I don't trust it. I think it's bad. Oh, I will never use that. I will never use Symbolab after what happened last week. I've lost complete faith in Symbolab. So you type it in, we're round to 2 places, and yep, I agree, 21.99. So number one's pretty straightforward, right? Any questions on this? All right, like I said earlier, this is going to be a very quick lesson today. We are on slide 6 of 12, if you are wondering. Okay, number 2. Well, let me go back to this page here so none of you try to peek underneath those boxes. Let's give you all of you, so most of you should have started number 2 by now. So let's say 3 more minutes to finish up number 2. And if you run into problems, try the other formula or be creative. Ask yourself, what do we have? What do we need to use these other formulas? And if there's ways we can maybe figure out missing stuff to help us find our final answer. So let's do 3 minutes. Ready, go. Well, Dianica, why'd you struggle with them? What was the issue, the problem? Yeah, go ahead. All of you can use the mic whenever you want.
I don't know if this is like a stupid question, but like the sides, how do you know which is A, B, and C, like the lowercase one?
It's always opposite. So, like, here's angle A, right? So, opposite of this angle would be this side. So, this would be little a.
Okay, that makes sense. And then, like you said, to be, I don't know what word you used, like creative for the equations that we use based off of what we have. I don't really, so we don't use the A squared equals B squared plus C squared. We don't use that. Like there could be other ways.
No, okay. So what you just said, a squared, b squared, c squared, that is the Pythagorean theorem, and that only applies to right triangles, which means one angle has to be a right angle, right? 90 degrees. So that only works for those. So you can't use them for any of these triangles.
So for these, we would use A squared equals B squared plus C squared minus 2BC and then cosine or sine. Okay.
Yep. And that's for the law of cosine. So you can use law of cosines for number 2, maybe. I don't know, or maybe I do know. Or you could use law of sine. So it's your job to figure out: do I want to use law of sines, which is what we did with number 1, right? So let me go to number 1. So, well, I'm sorry. That number one, we did law of cosines. Sorry. Yeah, this is law of cosines for number one. Number two, it could be law of sines. It could be law of cosines. It's up to us to figure out which one to use. So, with number one, if you tried law of sines, you would run into big problems. Um, we could not use law of sines because we would we would be missing we would basically have two variables in our setup if you tried using law of sines, and that would be a major problem, right? Trying to solve for one variable when you actually have two in your equation, that's bad.
And so how do we know which one to use?
You could use these general rules right here. So generally speaking, that would be true, but not always. Sometimes in some problems, you may have to be kind of creative, and maybe there's multiple steps to work through a problem. So not all problems. Like number one's very straightforward. Um, Doing it. Number two, maybe not as much straightforward. There might be maybe like two parts of the problem, which we will talk about here in a little bit. All right, so let's do a quick poll and give me a green check if you are done. Give me an X if you are stuck or not done. Um, and if you're not here, I am giving you the boot. I use baseball rules, 3 strikes and you're out. All right. Into the volcano. That's what Caitlin says.
So I have another question.
Uh-huh.
So for number two, let's say if we did use sine, would it be a squared equals b squared plus c squared minus 2bc sine a? Or is it a completely different equation?
Hang on a second. I'm trying to figure out how to boot somebody. It's a serious business.
Okay, so you just go to the arrow next to their name and just go remove from room. That's it. They'll be gone.
Into the volcano. All right. We're good. Oh, boy. All right. I'm sorry, Dianica. One more time.
So for number two, if it was going to be law of sine, would it be a squared equals b squared plus c squared minus 2bc sine a? Or is it a completely different equation?
No, that would be the cosine. You said cosine of A, right?
No, sine a.
No, no. So look at your identity sheet, and law of cosines would be basically what you just said, but with cosine A, not sine A. Law of sines is the fractions. Fraction equals a fraction. That's law of sines. So it uses like side over sine of angle equals side over sine of angle, or flipped. Law of cosines uses what you just said, but at the very end times BC times cosine A. Okay. Right. So number two, if you finished number two, go ahead and chat. Tell me what you got. I'm super curious. It's okay to be wrong. I feel like this was a harder problem for sure. I'm really curious everyone's answer. 3396, 3393, 3396, 3573, 3396. No, it's guys, it's okay if you're totally wrong. I really want to see what everyone got if they finish this problem. So for number two, you really obviously want to draw it out. You want to try to figure out, hey, if you're using law of sines, maybe circle the angle on the opposite side, what goes together, and say, hey, I need this and this paired, and I need this pair. And then maybe you're missing something, and then you have to kind of ask yourself, well, how can I find these different pieces somehow? So number two requires a little bit of extra thinking. Maybe it's a two-part. For me, it was a two-parter. Anybody here try law of cosines? Just curious. It's possible. Yes, it's very possible to do this problem using law of cosines. So Caitlin says she tried law of cosines. And is that how you finished number two, law of cosines? All right, Caitlin, on mic, are you able to explain kind of your process for number two of what you did? Got to reload. I think new row lies about having to reload because of mic issues, because it tells me that too, and I just don't reload it and it still works.
Can you hear me?
Mm-hmm.
Okay, so for mine, I set up and I wrote everything down. I wrote a list of like all the known information. And then to start, I did the law of sines. I did sine of C, which is 69. So sine of 69 over 35 equals sine B over 27. And then from there, I know that arc sine was then sine or 27 times sine of 69 over 35. So then I set up the cosine equation, which is the whole 27 squared plus 35 squared. And then for when I went to cosine A, for that, I put A as 180 minus 69 plus the arc sine of 27 times 69 over 35.
I like it.
That's how I finished it.
I like it. So Caitlin, she actually used both law of cosines and law of sines. So she first started out the problem by using law of sines to help her figure a piece out that she didn't have, but she knew she needed in order to use law of cosines properly. So she used both, which is good, and that's one of several ways to actually do this problem. Did anybody try just using law of cosines? They just use law of cosines, and you probably got stuck. Sarah, did you get stuck, or were you able to finish it? So Emily tried and got stuck. No, I finished, but got 13 something. Okay. I did, but didn't get stuck. So, Chloe, you used law of cosines from start to finish, and you got the correct answer? Oh, you used law of sines first. Okay. All right. So I'm asking anybody who actually used law of cosines, just that exclusively, and maybe got stuck right, is able to finish it. Yeah. So for people who tried using law of cosines, oh, by the way, the answer is in fact 3396. But let's kind of talk about this problem, approach different ways. All right. So if you try using law of cosines, you're like, all right, so I'm gonna just use this one and I'm gonna plug my stuff in. You're like, hey, I'm doing pretty good. I plug my stuff in. I only have one variable, a, right? And we're trying to solve for a, so we're doing pretty good. The problem is we have a squared and a, and well, that's kind of bad, right? And Sarah, is this kind of where you got stuck? Right. So I guess you could consider this a major problem. We have a and we have a squared, and that's definitely um, it's definitely no fun, right? To say the least, no fun. But there actually is a way to finish this problem. Um, like I did, you want to order stuff properly. You want to have the a squared stuff first, and then your term with a, and then your terms with, well, just numbers, right? Your constants. And you think, well, oh, maybe I could just factor this using the simple method or whatever you guys called it in past math classes. But, well, it's not so easy to factor because we have, well, large numbers, we have a cosine in there, and, well, it's still no fun. Well, one thing that always works is what? What formula did you learn probably in grade school that you can use to solve quadratics? What formula can we use to solve quadratics? Which formula can you use to solve quadratics? Yes, the quadratic formula. I gave the answer away in my question. I thought I was giving too much away. Yeah. Oh, did Caitlin say it first? I didn't see it in chat. I'm sorry. Let me scroll up and see if I can see where she said it. Oh, she did say it. Yeah, the quadratic formula dot 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 question mark. Yes, you are correct. You are correct. Sorry. Yeah, we could use the quadratic formula. So in this problem, so this is like saying x squared minus 2x 27 cosine 69 plus your constant. So in the quadratic formula, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. That formula, a in that case would be 1, b would be, well, that stuff I wrote down, and then c would be, well, your constants. And then you want to kind of leave it in that form. Because you don't want to round. C, you could actually type that in, hit enter, you get a really big number. That should be fine. For your B variable, you would just do 2 times 27, which is what, 54, and leave cosine 69 as that, so you don't round your values. But yeah, you would just plug A, B, and C into the quadratic formula. Type all that in, hit enter, and then you would have your two answers. The one that's positive would be the correct answer because you can't have negative angles. Well, in this scenario, you can't have negative angles. All angles should be positive in this diagram, and then all lengths should be positive. So whatever answer you get that's positive would be the correct answer. So I didn't finish it because, well, that's no fun doing it that way. So I went ahead and just kind of stopped here to show that it is possible, but we're not going to do it that way because that's no good. Yep, that is gross. I agree. All right. So the way that Caitlin did it, she first used the law of sines. And we do that because we're trying to figure out one of the angles. So let me use my pen here. So we're trying to figure out angle B. So our goal here is to find side BC, which is little a, right? This is opposite of angle A. So we're trying to find that. And we couldn't use law of sines right now because we don't know what angle A is. So law of sines right now would not work because we have two variables in this scenario, little a and big A. So that's why we couldn't use that. But we do know what opposite of side 27 length is. Let me kind of back up here. Let me delete that. And then I'm going to circle what we're working with here. See, but these two, we could use law of sines because now we're only solving for one variable, angle B. And then Caitlin kind of illustrated us with her description. But once you know your angle B, which we're going to find using the law of sines right now, once we have angle C, angle B, we can find angle A, because what do all the interior angles of a triangle add up to? 180. Yes. So, once you have angle B, you just do 180 minus 69 minus whatever angle B is, and then we'll have our angle A. So let's kind of go on from here and see what's going on. So we just solve for angle B. And really, kind of right here, we really don't want to type this in because whatever we get as an answer will be rounded. And you really want to avoid rounding your work when possible. And it is possible to avoid rounding work in this problem. But I went ahead and just typed it in to show you that we get 46.07 for angle B rounded. And then once you know angle B, like I say, you do 180 minus those two angles to find your angle A. So I'm going to go ahead and write angle A in there, which is 64.93 rounded. So 4.93 degrees. All right. Let me just go ahead and back those off. All right. So then we have a choice. Caitlin and Chloe, they both used law of cosines from this point. Is that right for you two? Yep, so that's what Caitlin did. I think Chloe said she did the same thing. But really, we could use law of sines again. Couldn't we? Yeah, we could use law of sines again, sure. We sure can. And we know we can, well, because we know angle A. So I'm just going to circle these, and we would just use these pairs. We'd use 35 and sine 69, and we would use A and sine 64.93. And we would do law of sines that way. So I think that's what I did. I did. Yep, I did. And, we would just solve for x. And then that's how we get the final answer of being 33.96 rounded. Yeah, law of sines I think is usually easier, one to set up and also to solve. Whenever possible, I like using law of sines over law of cosines. It seems like it's less math work than law of cosines. Now I think I use law of cosines under, okay, so under this last blue box, I use law of cosines to demonstrate that you could use that as well. And look, and there it is. So for law of cosines, looks like we did a squared equals what is it? B squared plus C squared minus 2 times B times C times the cosine of angle A. So yeah, we had everything we needed. The only problem with our work is we use rounded work, right? That's the only problem. So on the next page, I do this exact same problem the exact same way, but I'm going to demonstrate of how we could actually finish this problem start to finish without using rounded work. So, maybe it's a good idea to do it both ways. You can kind of see, I think it's easier to follow when you use rounded work, right? And we know the answer that we should probably get. So let me go ahead and show that. So yeah, we do the same thing. We find angle B first, which we do, but rather than type that in to actually find the actual value of it, we are just going to, well, just use that. So then angle A is going to be 180 minus 69 minus angle B, which we're going to show the exact form. And the only thing that we can actually do here is do 180 minus 69 to simplify that at the very least. So angle A, that's the exact value. There's nothing else that I can do to simplify that, right? Because if I were to type that in, I would have to round my work. We don't want to do that. So we now know angle A, which is all that stuff. We can then use law of sines again. So we're going to have side x. Let me go ahead and write that in. So I'm just going to put an x here. All right, so we have side x over the opposite angle, right, which is angle A, which is all that stuff, right, equals this pair, 35 over sine of 69. And then we would multiply both sides by that stuff, all that crazy stuff. And then it would look like this. So I want everyone to type in all of this. It's really, we already know what the answer should be, but I want to see if all of you are able to type it in and get the correct answer. Yeah, Antonio, it's all about the details. I'm all about details. Now, I have to admit, your questions on your test and your quizzes are definitely not this hard. But I still think it's important that all of you should have, the skills that you're able to solve it. You can solve these problems, this problem. You can pretty much solve any problem, I think. All right, so everyone type it in, I hope. Maybe you're still typing it in, but you hit enter and you get that answer. So what I have highlighted in yellow, that is the rounded answer using exact work. What I have highlighted in blue, that's from the previous page of the rounded work. So, we're just comparing one versus the other. See how they're very close. So exact work, we get 95810. But then in the rounded work answer, we get, instead of a 0, we get a 6 here. So, but rounding the two places, 8 and 8, we get the same answer. Now, if I ask you round to the nearest tenths, hundredths, thousandths, 10,000ths, so if I said, hey, round to the nearest 10,000th decimal place, right? Exact work, we would get 0.9581, but in the rounded work, you would have 0.9582. And 1 and 2 would be very different. So, but because we only rounded to two places, it really didn't have much of an impact. And that's how we get same answer. I am using the Casio FX 115 ES. Which one are you using? Oh, you're right. Not everything's about me. I know this. Yeah. Honestly, what are you? Which one are you using? Like Caitlin asked. Which calculator are you using? You can steal my limelight. I don't want it. Well, which online? What's the website you're at doing this? Don't say Symbol Lab. I'll die right now. Desmo should work. So honestly, we'll come back to this because I only have 15 minutes left, and I really want to finish this lesson. So we'll come back and kind of figure out maybe what you're not typing in, and maybe you don't have it in degree mode. So that could be a big one. All right. So my last two examples. Let's get through this. Word problems. You'd be given a scenario when your TGA problems is a word problem like this. So in this case, a plane is flying westwardly direction towards a destination. It is currently 300 miles from its destination, but it is currently off its needed course, traveling 6 degrees south of where he or she needs to be going. The pilot travels for 325 miles, only to realize he or she did not get to his or her destination. How far does he or she have to travel now to finally get to where he or she wants to go? So, all word problems always draw a picture, and no surprise, it's going to be a triangle, right? So you're going to have a triangle. We have 3 points. You're going to have like your starting point in this problem, where you ended up, and then where you're trying to go. And then there's a lot of key words in here that kind of tells you which direction you're flying, where you're off course, things like that. So go ahead, everyone. Go ahead and draw a triangle, or even just a regular diagram. Maybe no triangle yet, of what this looks like. I'm going to give you 1 minute to try to create some diagram that represents what's going on here. Yep. Antonio, you are correct. 6 degree would be an angle measure. Yep. Got about another 23 seconds left. When the time runs out, is there a volunteer that wants to draw their diagram of what it looks like? Volunteer to draw what their diagram looks like. Nobody wants to volunteer. Well, let me
Lloyd
give you a.
volunteered.
Who's volunteering?
Lloyd volunteered.
Go for it. That is perfect. So here's your plane, right? This is my plane. Yeah, that's definitely a plane. And we're going westwardly. Is that the right word? Westerly. Yeah, westerly. So that means they're flying, in the west. That's going west, right? And which means if they're currently 300 miles away from their destination, um, this is where you want to go. But they're 6 degrees, south. Say south off course. Let's see, 6 degrees. Yep, south. So it means they're flying down too much. So this is where they get right. And then they travel 325 miles. Perfect. And then side X, that's the distance now between where you want to go and where you are. So yeah, that's perfect. This is like Chloe, I think, read my mind exactly, right? So you're going west. You're 300 miles away from your current destination. We'll say Arizona. I don't know, some cactus, right? We're 6 degrees south off course. We travel for 325 miles, and then you realize that you're totally off course, and you're super mad because no one's happy about going the wrong direction, right? So I think a lot of you can relate. This is maybe how you feel, and then you want to know how far away you are from where you're trying to get to, right? So yeah, we just draw really sweet pictures, diagrams, and then we solve them. So I'm gonna go ahead and I'm gonna not show the work for this one, but I do want to go on to the next word problem to go over that one before we actually solve these. So I think going over the word problems and setting them up is more important than the actual math, at least for today's lesson. All of you should now use this information and solve. So let's go on to this next word problem here, and let's set that up before we actually solve these. All right. All right. This one says a man is looking up to the top of a building, and his view makes a 44-degree angle. He walks forward 100 feet, and now his angle of view is 62 degrees. This kind of sounds like TGA for number 3, a little bit. All right. So how long is his line of sight after he has moved? Okay. So everyone go ahead and draw a really sweet diagram. So maybe pictures too helps. And I'll say, let's say, 2 minutes? Or 1 minute? 1 minute. Or a minute and a half. Yeah, we'll do a minute and a half. I'm telling you, I'm so indecisive. Minute and a half, ready to go. Sarah, I do that all the time. Daily even. Ouch. I hope you got big hands. I got a big neck. All right. All right, time is up. Let's do this. Any new volunteer want to draw a picture for us? All right, go for it.
All right, so it's not complete because I don't think we have enough info here, but I might be wrong. That's a horrible triangle. We'll roll with it. So this is gonna be the first one. It's a 44-degree angle. I can draw 4. That would be helpful. Okay. And then it's gonna be 62 degrees. And besides this, the only thing we know is this. I'm just gonna call this, I don't know, little a. Little a minus 100.
All right, so remember, for these problems, your diagram, you should be able to construct a single triangle. Right now you have 2 triangles, so you want to avoid that.
All right, well, I don't know how to do this then.
Well, you kind of do, right? I think you have the pieces, right? You're just think of it in like a real situation. Visualize yourself literally standing there, looking at top of a building, and saying, this is my angle, right? And then you're like, okay, I'm going to walk forward 100 feet. So, show that. Okay.
So like just combine these two into one?
Yeah. So
like literally put it inside of the other one?
Yeah. So, okay. So here's my building, right? And then, maybe this is you, right? And you're like, there's my angle, right?
I don't have arms, but okay.
Yeah. You don't need arms. Okay. Those are overrated. And you're like, there's that. And then you're like, oh, let's walk forward 100 feet or something. So then this is you again with no arms. You don't need those. And then you're looking up again. You're like, there's that angle again. And then you see how you now made a single triangle?
Yeah, I got you.
Yeah. So you want to think about what's going on in the situation and just kind of draw that scenario. And, once you draw it, hopefully you construct a triangle. So I'm going to use my Lego drawing that I did. I got my Lego building. It's pretty sweet. And then, here's Superman, Lego man or whatever. And he's looking up at the top of the building. Hey, it's totally 44 degrees, right? And then he's like, okay, I'm going to now walk forward 100 feet. And then I'm going to look up again at the building and say, oh, it's now 62 degrees. It's nice, right? And then you're like, well, I want to know what my line of sight is. So, there's your X. So the problem here, so the triangle that we drew, we know this angle, right? But the problem is we want to know the interior angle. How do I find this angle? Because we need that, right? We need we need this angle, we need this angle, and then we probably need this angle. But how do I find this? Yeah, 180 minus 62, right? We learned that in geometry, right? So these are these called complementary angles? Yeah. So when you have a straight line, it's intersected or whatever. I don't know what the definition is. Those 2 angles add up to 180. Or supplementary angles. Complementary is 90. You're right. Yeah, supplementary angles. That sounds right. So yeah, 180 minus 62, that gives us the 118. So then once we know that, how do I find this angle here? Yeah, 180 minus those 2 angles. Perfect. So you do a lot of typing in your calculator or some buttons. You hit enter, and we should get 18 degrees. Okay. So now we know all 3 of these angles, which is super helpful. We also know this side of the triangle, and then we're trying to find out this side. So now, based on that information now that we have to decide, is it law of sines or law of cosines? So looks like the time is now 11 o'clock. So I'm going to go ahead and give you guys the link to this lesson for those that have to go. But I'm pretty sure math, I actually have until noon. But if you have prior obligations, I understand. There's a link if you have to go. Right now, we're just going to go ahead and just solve these 2 problems. and see what they are. So let's start with this one. Yep. But math actually has until noon, Mondays and Wednesdays. But if you have to go, you have to go. I understand. But let's go ahead and go on. All of you, I want you to find the line of sight x. It's up to you to decide if you use the law of sines or law of cosines. I will give all of you 3 minutes. Ready, go. Emily, good for you. Good thing for you, they can actually rebuild that. They can try again. Yikes. Well, I could try again. About a minute and 20 seconds left to finish the problem. Okay, so round to the nearest hundredths. I didn't state in this problem, but let's do 2 decimal places. Yep, sorry, I forgot to put that on this page. All right, let's do another quick poll and let's see who. All right, green check if you are done, X if you are not done. Just trying to get an idea who's done. Green check done, X not done. It's like Virginia. Oh, she's back. Dianica, she just ran away. All right. All right, good, good. Whenever you guys hear your name called on this, do you guys freak out?
What do we round to?
2 places is fine.
All right, perfect.
It's like your heart kind of like skips a beat, freak out. Good. That's my intention. All right. So people who are done, what's the final answer? $224.8, 190.21. 224.8. Yeah, so this is a building. So yeah, I think a couple 100 feet sounds reasonable, or 100 feet, 150, something like that. I don't know. So these answers sound reasonable. Like people who are giving, I got looks like two answers, but they both sound reasonable to me. That they could both be correct. There's not like an obvious like oh man, your building's only like 3 feet tall. That doesn't sound right at all, right? Or your building is like 1,000,000 feet high, which doesn't sound really possible. Remember, there's what 5,280 feet in a mile. Oof, that would be ridiculous. 10,000 feet. That's like almost 2 mile high building. It's crazy. Let's see what the final answer is. I got 224.8. Okay, yeah, mistype. All right. All right. So I think we used what do we use sines, law of cosines or law of sines for this one? What about law of sines? Yep, I did too. You are right. So there's the work, and we just type that in, hit enter, and I'm happy. I think that the battle on these problems, these word problems, is drawing your diagram. Right? These are the you got to draw your picture. If you can't draw the diagram, you probably can't solve the problem, right? Okay. Questions on this problem before we go to that first problem we did? No? Okay. Well, let's go back to this problem. Let's do was 3 minutes too long or was it just right? Just right? Okay, 3 minutes. Ready, go. Everyone solve for X. This is our last example. Ooh. So, never mind. I have something funny to say, but I'll wait until we're done with the lesson. It's about coughing. So I'm going to put the poll up on the screen. Only give me the green check if you are done. Don't click the X yet. So if you're done, give me the green check. If you're not done, just keep working. And then when the time runs out, you can then answer. I just want to know who's currently, someone gave me an X. Obviously, following a one-step direction, we'll work on that. So again, green check if you are done, and X, nobody should do an X yet. So we've got about 40 seconds left. Keep working. All right, time is up. So if you are done, give me a green check. If you are not done, now give me the X. George, you still there? Danica, you still there? Barely. Me too. All right, looks like George is AFK. That's fine. You get tired of hearing me talk. I don't blame him. AFK is away from keyboard. Oh, he's back. All right, so you guys use law of sines or law of cosines? Cosines, sine, cosines. Looks like a lot of cosines, some sines. Tried cosines. Let's see, what did I do? I did law of cosines. Yeah. All right. So people who are done, what is the final answer? Remember, this is in miles, so it better not be 41 feet away from destination. Because this is 41 feet away. You know what? We wouldn't be mad. We would walk. Like, oh, we're only 41 feet away. Let's walk to where we're supposed to be, right? So this is miles. Yep, miles. Yeah. If I was grading a test and you got the correct numerical answer, let's 41.15, maybe that's right. I don't know yet. And you put feet instead of miles, I'd mark the entire. I don't do partial credit. I hate partial credit. I'd mark the entire thing wrong. I am the meanest grader. I promise you that. But I also promise you that you would learn quite a bit. Why would I give partial credit for mistakes? That's just rewarding bad behavior. I don't believe in that. So I think you learn from your mistakes, and if I mark everything wrong, then that hurts, and you learn the most from it. That's just my belief and my experience. It actually works. So yeah, 41.15 miles. Yep. So there's the work, and we type all that in, hit enter, and we are done. So I'm going to go ahead and stop the recording now. So thanks for hanging around, guys. And as always, I hope you learned something. See you all tomorrow.